Hi everyone. Just decided to do a quick little video to grab a couple more trig functions so that you have a chance to review this before the exam on Wednesday. So I'm going to start by refreshing your memory on the basic trig functions. So if you think about sine and cosine, they have a couple key points, and if you know those key points, then you know the whole graph, right? So let's look at sine. The key points on sine occur at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And as long as you know that sine of 0 is 0, sine pi over 2 is 1, sine pi is 0, sine 3 pi over 2 is negative 1, and sine 2 pi is 0, then you know the whole graph. You just plot these points and connect the dots. So that's sine on one period. Sine t. This is the t-axis. Okay? Same thing with cosine. We know it starts at 1, then down to the middle, down to negative 1, and back to the middle, and then it starts repeating at 1. And it occurs at the same interesting points: pi over 2, pi, 3 pi over 2, 2 pi. So it starts at 1, middle, negative 1, middle, and 1. So that's cosine. And by knowing those 5 points, all that we're going to do is we're going to apply a whole bunch of transformations. And when we do these transformations, these 5 points, 0, pi over 2, pi, 3 pi over 2, and 2 pi, they're still going to get used for reasons that we'll see in a little bit. So you just need to know these 5 points really, really well, together with a couple of extra little calculations, and we'll go through a couple of examples. Okay. So let's take a look at an example. Let's do negative 2 sine x, t minus pi over 6. We're going to graph this trig function. So I've mentioned already that the trig functions have a quote-unquote starting point. And if you take this starting point, then from that starting point, you're going to add those key points. You start, then for the sine function, you're going to peak, then you're going to go back to the middle, then you're going to reach the low value, then you're going to go back to the middle. So we need to figure out what's the starting point. That's so the phase shift of a trig function says take the inside piece of that function, set it equal to 0, and solve. So in this case it's real easy. Just add pi over 6. That's your starting point. Okay. From that starting point, you're then going to add multiples of the period over 4. And those are the key points where all the interesting stuff on this function happens. Okay, so what do we have? The period, remember, is 2 pi over the size of the b term. Usually the b value is going to be positive. In this case, b is 1. So the period is 2 pi. We then take the period over 4. Period over 4, that's where all the interesting stuff happens. You start at the beginning. Period over 4 is where it peaks. Period over 4 is, add a multiple of period over 4, you're back to the middle. Add a multiple of the period over 4, you're going to bottom out. and then add a multiple of the period over 4, and you're going to reach the beginning. Okay? So, period over 4 then, it's going to be 2 pi over 4, which is pi over 2. Okay? So, now let's go ahead and continue on. What do we do with these two values? This is our starting point. And this gives us the key points. Okay? So, let's get started. We're going to use these two values. So all we do is just get a set of axes set up. This will be our t-axis. Our starting point was pi over 6, and so all we do is just plot that right here. So pi over 6, that's our starting point. We're going to add pi over 2 to this. When you add pi over 2, that gives you 4 pi over 2, which is 2/3. 2 pi over 3, okay, 2/3 pi. Add another pi over 2, you're going to end up at 4 pi over 3. 5 pi over 3. 5 pi over 6. Add another pi over 2, you're going to end up at 8 pi over 6, which is 4 pi over 3. And add another pi over 2, you're going to end up at, let's see, this is 8 pi over 6, which add another 3 pi over 6, you get 11 pi over 6. Okay? So all of these, all that we did is we took our starting point and we added pi over 2, which if you write this in terms of 6, that's 3 pi over 6. So add 3 pi over 6 to get here, add 3 pi over 6 to get here, add 3 pi over 6 to get here, and so on. Okay? What do we have? That's 1 pi over 6, 4 pi over 6. So I guess this would be 7 pi over 6. That would be 10 pi over 6. This would be 13 pi over 6. Okay. So you just add the period over 4 multiple times. And now, these key points, you're just going to plug them into the function. So the function is this guy right here, and we're going to take f at the first point. That's our starting point. So let's go ahead and take a look at this basic trig function, the basic sine function. The starting point happened at 0, then pi over 2, then pi, 3 pi over 2, and 2 pi. We're going to refer back to this in a couple of minutes. Okay, so let's go ahead and input this pi over 6 into the actual function. So negative 2 sine pi over 6 minus pi over 6. What does that give us? Gives us negative 2 sine of 0. Okay? What is sine of 0? 0. So that says that right here, the y value is 0. Okay. 2 pi over 3. So what do? We've got 2 pi over 3 is the input value. That's where one of the key features happens. Input that. We're inputting it right here. So 2 pi over 3 minus pi over 6. that gives us, what is that? That is 4 pi over 6 minus pi over 6 gives us 3 pi over 6, which is pi over 2. Well, that's interesting. For the first input value, when we plugged it in, we got sine of 0, which is right here, right? When we plugged in this next key point, we plugged it in, we got sine of pi over 2, which is right here. So what is sine pi over 2? That's 1, so we get negative 2 times 1, which is negative 2. So let's plot that point. Okay. F at the next point, f of pi. What do we get? Negative 2. No, sorry, not pi. 7 pi over 6. So negative 2 sine 7 pi over 6 minus pi over 6. Okay? If you have 7 pi over 6, you subtract 1 pi over 6, you get 6 pi over 6, which is pi. And what is sine of pi? Sine of pi is 0. So you get negative 2 times 0. So once again, we notice that we got this key point right here. Okay, so first key point 0, pi over 2, pi. 0, pi over 2 pi. So whenever you plug these values in and simplify the inside pieces, they always simplify down to those key points that we know from the basic sine function. Okay? So there's our new point, 0. And at this point, most people can already see the pattern. We've started at the middle, went down to the bottom, back to the middle. So this next one, we already know it's going to be up at the top. And then we'll go back down to the middle. But just for confirmation, let's plug these values in. So f of the next key value, 10 pi over 6. We get negative 2 sine 10 pi over 6, goes right here, minus pi over 6. What does that give us? 9 pi over 6. And what is 9 pi over 6? That's 3 pi over 2. Sine 3 pi over 2, we know is negative 1. Negative 2 times negative 1 is 2. Okay? And so at this point, 10 pi over 6, the y value is 2. And now, f at the last key point, 13 pi over 6. You plug that in here for t. So what do we have? 13 pi over 6 minus pi over 6 gives us negative 2 sine 12 pi over 6. And what is 12 pi over 6? That's just 2 pi. And what is sine of 2 pi? Sine of 2 pi is 0. Right? Sine of 2 pi is 0. So at this point right here, we've got 0. And so we have the full cycle right here, the full period. And all we do, we just connect the dots. It goes down to the bottom, back to the middle, peaks, and back to the middle. So this is sort of the, very systematic computational approach to graphing trig functions. Find your starting point. That's given by the phase shift. It says set the inside equal to 0 and solve. That's where your trig function is going to quote unquote start. Once you have that starting point and the period, 2 pi over b. That period, you divide it into 4 equal pieces. So here's one period. We already know the period is 2 pi over b. You're going to divide that into 4 equal pieces. You divide that to where you know exactly where those key points are going to happen. Then all you do, you know where those key points are happening, so you just plug them into the function, and that gives you those values. You plot those values and just connect the dots, right? Now what you do is you say, okay, I know all the properties this is supposed to have, right? This thing is supposed to, first of all, The 2 says it's going to be stretched vertically by a factor of 2. The negative says it's going to flip vertically. The t minus pi over 6 says it's going to shift right by pi over 6 units. And so what has happened in this graph? Well, the original one, between plus and minus 1, it's got that range plus and minus 1. This one doubled in size. The period, 2 pi, matches with the period of 2 pi of the original, because this t is 1. The coefficient of the t value is 1, so it's not, the period doesn't change at all. The negative here says it's going to flip, right? The original started by going up and going down. This one started by going down, then going up. So you just use all those properties of the trig function to check and make sure that your graph is in order. And it is, right? Should be shifted to the right, pi over 6, it is. Should be stretched by a factor of 2, it is. Should be flipped from how it is usually, and it is. So that says everything looks like it went through okay.